69.6, 70.5. Okay, so this is now 66, you go to 70. And do this only if there is enough space. If you have big samples, you might not even have this space. So this sample is very flat, therefore I have a lot of room.
How do you know if that distance is good enough?
The recommended distance is 8.5. Again, it is not always possible to get it. 8.5 is recommended, but if you go slightly above or slightly below, it would still work. It's just not the optimal distance.
And how do you know that distance?
It was written in the manual. Oh, how do I know that this is 8.5? This shows you the working distance.
Oh.
We go to the image mode. And here you can see the working distance.
But then when you focus, it will change, right? And then it should be 8 approximately.
When the image is in focus, the ideal working distance is 8.5.
Okay.
So since now the sample is tilted, you need to do tilt correction. And when you remove the sample, don't forget to deactivate it, because people who come after you and who know nothing about Ebsd will not be able to recognize.
Yes, and that happened once.
To you?
Someone else did forgot to turn off the
See,
options.
these people are, they don't care about other people, they only care about themselves.
What about dynamic focus?
Wait, so quickly. Why don't we see anything here? Something's this time. Okay, let's try to focus. Okay, mechanical evolution is whole. It's whole everywhere. We're gonna start soon. She's recording. city seconds and good. Where's the second sample?
Is the edge coming close to the bodies or far away?
When you move along this side, this line, then it's not dangerous. It's dangerous when you move on this and also this of course. Okay, let's be systematic. Go from edge to edge. Okay, so this is the edge. Nothing. Now we're going to dangerous thing.
This is up and down. This is down, yes?
This is done.
What?
It's not dangerous.
But anyway,
Dangerous what?
what I previously said is that when you move along this side, basically move along this direction, so it's not dangerous. You're not going to hit anything.
That's
But-
X? Or which one is it? Yeah.
That's X, yes.
It's X here, but on the screen you see
Yeah,
it's
yeah.
in this direction.
And if you're
But if you
moving
go up
Y,
and down, then it might be dangerous.
so if you're moving Y, then will be.
Yeah. Oh, yes.
Okay.
One of them is close, one of them is away. Which one of them is close? Is this?
Oh, I'm trying to find another sample.
Yes.
So that,
But you didn't try that direction.
so another sample, it's the same sample. It's the color. This is stage. Okay, there's nothing there. Okay, this is the second one. Ah, they all both have holes. Okay, so maybe this is the second one.
This one is more than the second one, is it?
They are colors at the same time.
Because they are embedded together, correct?
I don't know the history. I just see that the quality is bad. Equally bad. Yes, this was sample one. So now it's 18.4. I guess it will not be possible to go to 8.5. Don't guess, I know it will not be possible. At least we can get as close as possible. Make sure nothing touches this focus.
So that's the closest you can get.
Be very careful, okay?
Huh?
Be very careful. Make
Yeah,
sure
yeah.
that nothing, not this part touches this.
You have a sensor, correct?
No. You touch, you get fined.
Up to this level.
No sensor here. The sensor is under for Ebsd, but when you move here inside, you trust your eyes only.
stance you said ideal one is 8.5.
I think this is the best we can do now,
13.
and I don't think that we should build Ebsd patterns anyway, because the surface is bad. So we need Aztec. Don't confuse Aztec crystal and Aztec for.
Yeah, it's the same for EDS and
Okay.
This is EDS.
Well, it doesn't matter. First, we need to insert the detector. So the insertion goes in 2 steps. One is click, and then it stops here.
Stops completely.
Yes, that's the first step. It's quick because it's not dangerous. The second step is slow, in order to make sure that you have enough time to stop. So you press again insert, and you will hear that it comes very slowly, and be ready to press stop when you see it's dangerously close. So for this, there is a sensor which in theory should stop the detector when it becomes too close.
Automatically?
In theory, but can you trust computers? So always trust your eyes. There's still enough distance, so here you can see the position, it's 160 whatever, 7, 8. It will stop at 175, I think, almost. Yes. So 175.9. You see, it was close, right?
Very close, yeah.
Yeah. So anything closer than this can be dangerous. The sensor did not activate because the sensor didn't think that it was dangerous. But you never know. So always watch what happens there and be ready to stop if you see that it's tiny distance and it's still moving. And it's still far away from 175.9. So then it's dangerous. Better stop before you damage the detector. If you damage the detector, you will be famous at DTU Construct.
I
People
imagine.
will remember your name.
Is it anything you have to do with
Because it doesn't only cost money to repair, which is expensive, but also
time for all this?
Time. People might not be able to use the system for maybe 2 months because this has to be collected by a service engineer. There is no service engineer stationed in Denmark, so this service engineer must come either from Germany or Sweden. It's not immediately. I will be there tomorrow. Maybe it will take a couple of days before they come. Then they will send it to England. It's Oxford instruments. It will take time to detect it to arrive, then they will disassemble, prepare, send it back. It will take time. And in the, let's say, best case scenario, you will scratch the screen. The this is bad, but not too bad. If you destroy this one,
The
this
RGB.
is, it's definitely sending to Oxford. Wait for a couple of months. And if it is summertime, then it may take a little time.
Do you have to do
Okay.
something with proximity?
Huh?
Do you have to do anything with proximity?
Proximity is always on when it is inserted, but there are some
But it's automatically on?
idiots who first disable it and then insert.
What?
Yeah. I have seen this.
What's that?
First December?
You can disable. Okay, not disable. Disable.
Yeah, disable.
Disable. And then insert. And then the sensor doesn't work, even in Syria.
So it should always
Yes.
be
Oh,
on.
when you insert.
When
Yes.
you insert, when you retract, it's not dangerous, it doesn't have to be on.
But you need to be off also when you start imaging. Because that
We
should
should
be
come,
the
we
noise.
should come to this. So, right now, it is fully inserted, then you can disable.
What if you let?
Then you might have some problems with image quality.
Okay, so important to be.
Recommended, recommended, yes.
Okay.
Okay, so we go back to the this one. See our wonderful service. So I think I can promise you that we shall not get any good patterns from this service. It looks bad. So here somebody before us used the EDS system. We need to change to the Ebsd system, and the idea is the same. You start from here and end up here.
Scan.
So definitely it's not titanium. We need to find faces that you're going to study. You have many faces. You have I don't know how many faces.
And if you don't know which faces you have?
You better know.
Okay.
So there are several databases. 1, 2, 3. You need to know what faces you expect.
You cannot change that later? No?
The software needs this information to find
Yeah, but
patients.
because in the other microscope in Mexico, you can, for instance, have only one face, and then you can add some others when you have the.
Maybe you
when it's
save,
done,
you save the patterns. In this case, you can do
Yeah, yeah.
faces, but we don't save the patterns.
Ah, okay. So if you don't have it in the beginning, then it's not possible to do
Well,
it later.
our maps are usually pretty big, so like millions of pixels. And for every night session, we would have to buy a new practice.
Okay.
So that is why it's always a good idea to know what faces you have. And these faces must be right. For example, if you have aluminium and forget to choose the right face, and it will be FCC iron and steel work, but the accuracy might suffer. So the software will still find solutions because the crystal structure is the same, but the units of parameters are not the same. They are similar but not the same.
Okay.
A lot.
What about, for example, if we want to choose like some intermediate particles, like sigma phase, for example,
Then you need to know what the composition of this phase or the chemical formula.
and then how to add that?
You will not find sigma phase here.
How to add it if you want to add
You need to know the formula.
If you want the formula.
Sigma is the name.
Yes, and if you found the formula, how to add that one?
Then
You need
go
a
through-
zip file, kind of, no?
How?
Go through.
Okay, from the other one, inorganic.
focus a lot of stuff here.
Yeah.
And this is possible to have ferrite and martensite distinction or not?
And I don't think that your software can do it.
To have ferrite inside that?
What's a different
Distinguish
phase?
between ferrite and martensite. So the Ebsd software is not super accurate. So it use slight difference in units of quantities. It will not tell you what is what. As I told you, you can analyze aluminium or stainless steel. If this is steel, it still works.
Mhm.
So you have aluminium and then you present the data. Did you study stainless steel? I don't remember that. The software will show you, you studied stainless steel. Because it did change. The face is here. So let's see whether we have a couple. Yeah, of course we have. Okay, we have chosen. I have no idea about the geometry, so I will not apply any sample notation. This you can change later.
Mm.
So scan image. Let's see whether we get any diffraction patterns. So B must be on. Wow. I didn't expect that. Seeing this quality, okay. Okay, it's actually surprising. Okay, then let's reduce modification and start playing this dynamic focus. I don't think that we want to image this stretch. Need to find region which doesn't contain a lot of scratches. If your sample is well polished, then you're lucky. So, I was given that sample.
Not always.
Okay, so the focus here should be okay. And we can also check the focus. At the top and bottom. So when you tilt the sample, there can be some defocusing at the top and bottom because the distance from the physical distance of these edges from the pole piece is different.
Mhm.
This part is closer, this part is further away. And now you shouldn't use this focus knot. You use focus knot when you focus on the center.
What? What do you mean?
I mean what I told you.
Focus on.
So the center region
Uh-huh. Should be always in focus.
must be focused with this knot.
Uh-huh.
But if you go and check focus at the
The
bottom
top?
and top, then don't touch this. Then you should
Ah.
use this dynamic focus. Okay?
And it will automatically.
No, it will not be automatically. You need to
Ah, okay.
write the right focus.
Mhm.
So you simply use either this or that, but that's not a good idea. I would recommend that you slightly usually it's positive.
You should do it in both, in bottom and on top, or only in one of them.
Imagine if your sample is not perfectly flat,
Mm.
then it's a good idea to check both top and bottom. I think it's
Okay.
it looks
So you focus in the center of the sample, and then you use out dynamic
Yes.
for top and bottom.
Yeah.
if
only
needed.
when it is tilted.
Only, yeah.
Otherwise, it doesn't make sense. Okay, so yeah, let's go back to 300. Take another image. Okay, now actually the quality is much worse.
Mm. And a few places should.
What other chain you use? What other chain you use usually?
What?
What are the other chains that you use usually? Which are